Okay, so you have typed something into ChatGPT or Claude and it just figured it out. It searched the web, wrote some code, ran it, fixed an error, and handed you the answer. And you are sitting there thinking, wait, did it just do everything on its own? Yeah, it kind of did. And that's what we are digging into today. Not the surface level statement like AI is magic stuff and stuff like that, but the actual mechanics. How do AI agents work under the hood? We are starting with what people get wrong before we get into what's actually happening. Most people think an AI agent is just a really smart chatbot, like a better version of autocomplete, but that's not what's going on inside. A traditional LLM, that is a large language model, takes your input, predicts the next word, outputs something, done. An agent is different. It's built around a loop. It perceives something, your input, your data, the state of the world, then it plans, then it acts, calling tools, running code, browsing, then it reflects on what happened. And then it does it again. That loop is a core idea, and everything else is built on top of it. So, what's sitting at the center of that loop? The brain of the whole operation. At the center of every AI agent is an LLM, that is a large language model. But here's the thing, the model itself doesn't browse the internet, it doesn't run your code, it doesn't actually do most of the things that you think it does. What it does is reason. It decides what to do next. It says, like, okay, given everything I know, I should call the search tool, or I should write this function, or I need more information before I can answer this particular question. The LLM is a decision maker. The tools around it are how it acts on those decisions. Which brings us to tools, because this is where it gets genuinely interesting. Tools are basically functions the agent can call. When the model decides it needs to search the web, it doesn't actually go to Google. There's a function called web search that someone built and the model just calls it. Same with code execution as well. The model writes Python, passes it to the code interpreter, and gets the output back. File access, email, calendar, databases. All of these are just functions. The agent decides which function to call, when, and with what inputs. That's it. It sounds simple, but the fact that you can compose these tools in real time on the fly based on what the task needs, that's really powerful. But calling a tool once is easy. What makes agents impressive is what happens when they need to think across multiple steps. One of the key breakthroughs in making agents actually useful was something called React, which is reasoning and acting. The idea is almost embarrassingly simple. You let the model think out loud before it does anything. So instead of just getting an answer, you get something like, I need to find the population of three cities, then compare them. So let me search for each one of them first. Then it acts. Then it observes what it got back. Then it thinks again. This thought to action to observation loop is how agents handle tasks that are way too complex to solve in one shot. It's not magic, it's called the structured reasoning with checkpoints. Now, thinking across steps is great, but what about actually remembering what happened? Memory in AI agents isn't one thing, it's actually four different things. First, in context memory. That's just the conversation window, everything the model can see right now. Second is external memory, a vector database or document store the agent can query, basically a long term memory bank. Third is episodic memory, that are the logs of past runs, past decisions, past outcomes. And fourth is parametric memory, the knowledge baked into the model's weights during training. Most real world agents combine all the four. The context window handles the immediate task, external memory handles recall, episodic memory helps the agent learn from experience, and parametric memory is the baseline knowledge it starts with. Okay, so the agent can reason, it has tools, it has memory. What does the architecture actually look like when we put all this together? Let me paint the full picture. You send a message, it hits the agent core, that is the LLM. The model reads the system prompt, your message, any relevant memory retrieved, and any tool descriptions it has access to. Then it decides, do I have enough to answer or do I need something else first? If it needs to act, it calls the tool, gets the result back, and that result gets folded back into the context. This loop continues until the model is satisfied with the answer. The whole thing is orchestrated through something called a system prompt, which is basically a long set of instructions that tells the agent who it is, what tools it has, and how to behave. And when you have multiple agents working together, that's where things get really interesting. Here's where things scale up. Instead of one agent doing everything, you build a team. An orchestrator agent sits at the top. Its job is to basically understand the overall goal and delegate subtasks to specialized agents. The research agent goes and gathers information. The code agent writes and tests the solution. The writer agent turns everything into a coherent output. The orchestrator assembles the result. This is how systems like AutoGPT or Crew AI work, and it's also why agents can handle genuinely complex multi-day workflows. Each agent is focused. The orchestrator keeps the big picture. That's it. But with all this capacity comes a real question. What can go wrong? Agents fail in some pretty specific ways that are worth knowing about. First is hallucination. The model might confidently call a tool with wrong parameters or invent a URL that doesn't exist. Second is tool misuse. Without good guardrails, an agent might delete something when it meant to read it or send an email when it was just supposed to draft one. Third is runaway loops. The agent gets confused about whether it's done, it just keeps calling tools in a cycle, spending compute and potentially doing damage. The fix for all this is the same: human in the loop checkpoints, clear tool descriptions, and hard limits on the number of steps. So, knowing all this, how do we actually evaluate whether an agent is working properly or not? This one is underrated. Most people build agents and just check if the answer looks right or not, but good evaluation goes a bit deeper. How often does it actually complete the task end to end? How many steps does it take? Are the tool calls it makes accurate and appropriate? How often does a human need to step in and correct something? These metrics matter especially when you're putting agents into production, because an agent that gets the right answer 80% of the time and destroys data the other 20% is not very useful agent. Now let's take a step back for a second and talk about where this is all heading to. Agents today are genuinely useful for specific slice of tasks, the ones where steps are relatively clear, the tools are well defined, and there's human around to catch mistakes. Automated research, writing pipelines, code generation, data analysis, these all work well. Where it still gets dicey is the long horizon planning, genuine self correction, and anything where goal is a little ambiguous. The models are improving fast, but right now the sweet spot is augmentation, that is, agents that handle the grunt work while you handle the judgment calls. So, what does all this mean for you? Here's a mental model I want you to take away with. An AI agent is just three things working together: a reasoning engine, that is the LLM, a set of actuators, that are the tools, and the memory, so it can stay coherent across steps. Agents are loops, not straight lines. The model decides, the tool executes, and the results come back. That cycle is it. That's it. Everything else you see, AutoGPT, Devin, Claude's computer use, whatever's being hyped next week, it's all some variation on that loop. The fancier it looks, the more complex the orchestration is, but the core idea remains the same. If you found this video useful, like and subscribe. Thank you. I'll see you in the next one.